Meet our group members. We are Group 6 from Cohort 25, pursuing the Bachelor in Environmental Health and Safety at Marcy University. Together, we have collaborated to prepare this case study on palm oil mill effluent, POME, combining our knowledge and teamwork to propose an effective industrial wastewater treatment solution.
Hello everyone, my name is Audrey and I will be presenting the introduction section of our assignment entitled Real World Case Study, Designing a Custom Treatment Plant for Industrial Wastewater. So we are focusing on palm oil mill effluents or POME. So Malaysia is one of the world's largest producer of palm oil. However, palm oil productions also generates a large amount of wastewater. It is estimated that around 2.5 to 3 cubic meters of POME are produced for every ton of crude palm oil processes. So POME is a thick brown liquid produced during the sterilizations, clarifications, and separation process in a palm oil mill. Although it is not toxic, it contains a very high concentration of organic matter, suspended solid, oil, and nutrients. If this discharge without proper treatment, it is a very high with BOD, COD, and TSS levels that can reduce the dissolved oxygen amount in rivers, pollute water sources, and also harm aquatic life and nearby communities. So therefore, proper POME treatment is essential to protect the environment. To overcome this environmental issue, POME must undergo several treatment processes, including physical, chemical, and biological treatment. So these processes work together to reduce pollutants and ensure that the treated effluents meets the required discharge standards. So besides protecting the environment, modern POME treatment also support the circular economy by promoting water reuse, reducing greenhouse gas emissions, and producing biogas as a renewable energy sources. So in this assignment, our group will discuss a real-world case study of POME based on published research. We will analyze the wastewater characteristics, propose suitable treatment plant designs, and evaluate its cost, feasibility, and compliance with Malaysia effluent discharge standards. That's all from me. Thank you.
Good day everyone. Today I will present a custom treatment plant design for palm oil mill effluent or POME. This case study is based on Malpom Industries Sinerberhad in Nibong, Tebal, Pulau Pinang, Malaysia. The main focus is to design a suitable wastewater treatment system based on the characteristic of palm oil mill effluent and Malaysian discharge standard. Okay, why POME needs treatment? It needs proper treatment because it contains high organic matter, oil and grease, and suspended solid. If it is discharged without treatment, microorganisms will use up oxygen in the water while breaking down the waste. This can reduce dissolved oxygen and harm aquatic life. The raw sample also has high temperature and acidic condition, so treatment is needed before final discharge. This case study is suitable because the wastewater sample was collected before entering the treatment plant. This means the sample represents raw wastewater or the worst condition before treatment. The main design question is how to reduce the pollutant load so that the final effluent can meet Malaysian discharge requirements. The raw palm oil mill effluent sample shows very high pollution levels. COD is the highest organic load indicator, followed by total solids, oil and grease, BOD, suspended solids, and ammonia nitrogen. These values are important because they help us decide the suitable treatment process. For example, high oil and grease requires oil separation, while high BOD and COD require biological treatment. Based on the comparison, the raw sample exceeds the Malaysian discharge limits by a large margin. Oil and grease exceed the limit the most, followed by BOD and suspended solids. This shows that one treatment method is not enough. The design must include physical treatment, biological treatment, solids removal, cooling, and final polishing before discharge.
I'm Lilin, so I will explain the part of problem analysis of palm oil meal effluent, or in short form named POME. So untreated POME is a thick brown liquid produced during palm oil processing. So if it is discharged directly into the rivers, so it can seriously pollute the water and harm the aquatic life lah. So as you can see in the table, the pollution levels are very high. The BOD is over 10,000 milligram per liter, which is more than 100 times the DOE limited. So the oil and grease level is more than 300 times from the allowed limit. So the suspended solids, ammonia, nitrogen, and temperature also exceed the DOE standards. So from the results, we can see that the wastewater does not follow the DOE standards. Most of the pollution levels are much higher than the legal limits, so it is not safe to release this wastewater into the environment. So to protect our rivers and aquatic life, the wastewater must be treated until it meets the required standards. So now let's look at the environmental impacts of untreated POME. So first is oxygen depletion. High BOD and COD use up the oxygen in the river, so making it difficult for fish and other aquatic organisms to survive. So for second one is habitat damage. So oil, grease, and suspended solids will block the sunlight and cover the riverbed. So it will affect the aquatic plants and animals. So for the final one is toxic eutrophication. So high ammonia nitrogen will cause the excessive algae growth. When the algae die, they will reduce the oxygen in the water and make the river unhealthy. So for the overall, untreated POME can seriously damage the aquatic environment if it is not treated properly. Okay, that's all for my part. Thank you.
Hello everyone, I'm Dorina Anajopes. So now I will present the proposed treatment plan design for palm oil meal effluent, or POME. POME contains high concentration of biodegradable organic matter, suspended solid, oil and grease. Therefore, an integrated treatment system is proposed to ensure the wastewater is properly treated before discharge. The treatment begins with screening, followed by a cooling and equalization tank to stabilize the wastewater. It then passes through an oil and grease trap to remove free floating oil. Next, the wastewater undergoes anaerobic digestion, which significantly reduces biochemical oxygen demand, or BOD, and chemical oxygen demand, or COD, while producing biogas as a renewable energy source. The effluent is then treated in an aerobic tank and a secondary clarifier before passing through a sand filter, activated carbon filter, and disinfection unit to improve water quality. Finally, the sludge is treated through thickening and dewatering before disposal or reuse. So, why this treatment system is proposed? This treatment system is designed based on the characteristics of POME and combines physical, biological, and tertiary treatment processes. The physical treatment removes large solids, stabilizes the wastewater, and protects downstream equipment. The biological treatment effectively reduces organic pollutants. Anaerobic digestion also produces biogas, making the system more sustainable, while aerobic treatment further improves the effluent quality. Finally, tertiary treatment removes remaining suspended solids, color, odor, and harmful microorganisms before discharge. Overall, this proposed treatment plan provides an efficient and environmentally friendly solution by improving pollutant removal, supporting renewable energy recovery, and ensuring compliance with environmental discharge standards. Thank you.
Hello everyone. So I'm going to present the cost and feasibility consideration for palm oil mill treatment plan. A treatment plan must be technically effective, but also feasible for operation at a palm oil mill. The capital cost includes land, tanks or ponds, pumps, screens, oil separations units, aerators and filters. Operating costs includes electricity, manpower, maintenance, chemicals if needed, monitoring and sludge handling. Bond-based biological treatment is often practical where land is available, while advanced systems such as covered digesters can be added in phases. A phased implementation is recommended so that the mill can control costs while improving treatment performance over time.
I'm Dorothy Anaala. For the conclusions, this report shows that untreated palm oil mill effluents, or POME, has very high level of organic metals, suspended solids, oil and grease, and nutrients. Because of this, it is not safe to discharge directly into the environment. The case study result clearly show that most of the wastewater characteristics fall above the limit set by the Malaysian Department of Environment, or DOE. Therefore, proper treatment is needed before it can be released. To solve the problems, a multi-stage treatment system was proposed. It uses combinations of physical, biological, and tertiary treatment processes. Each unit has its own functions to remove different types of pollutants. The use of both anaerobics or aerobics treatment helps to improve the overall performance of the system. In addition, the design supports sustainability by recovering biogas and managing sludge properly. This helps to reduce environmental impacts and also makes good use of resources. From the technical and economics point of view, the proposed system is practical, especially for palm oil mill because they have enough land. The cost of for buildings and operating the system may be high, but choosing the best approach allows the mill to meet the regulations step by step and manage the cost is more better. In long term, good palm oil mill effluent treatments will protect our water resources and public health. At the same time, it supports the sustainable growth of Malaysia's palm oil industry by balancing environmental responsibility with operational needs. That's all. Thank you.